This small rock could change everything. Because if it is what many scientists believe to be true, then it leads to only two possible conclusions. Either Mars and Earth share the same biogenesis, or, by the very nature of probability, the universe is teeming with life. It's a bold claim, but a reasonable one. This is the truth about NASA's recent discoveries on Mars, and what it means for us and the universe at large. The rock at the centre of this story was found by NASA's Perseverance rover in Jezero Crater, a region of Mars that billions of years ago was once a river delta feeding into a standing lake. That matters because deltas and lake beds on Earth are some of the best places we know for preserving traces of ancient life. Fine sediments settle gently. Organic material can be trapped and protected. It is exactly the kind of environment where biosignatures, if they ever existed, would be most likely to survive. Perseverance drilled into this mudstone and analysed it using multiple instruments: spectroscopy, X-ray fluorescence, and laser-induced breakdown spectroscopy. Tools designed to identify chemical composition, mineral structure, and organic compounds at microscopic scales. What it found was not a fossil, it was not a microbe, and it was not proof of life. What it found were patterns. The rock contains organic carbon compounds embedded within the mineral matrix. It also contains iron phosphate and iron sulfide minerals, arranged in textures that, on Earth, are often created or altered by microbial activity. Importantly, none of these features alone proves biology. Every one of them can, in principle, be produced by non-biological chemistry under the right conditions. But what has made this discovery so striking to scientists is the combination of features appearing together in the same geological context. A context that, independently, is known to have once supported liquid water. On Earth, this specific package of textures, minerals, and organics is most often associated with environments where microbial life once processed energy from its surroundings. That is why NASA and the scientific teams involved use a carefully chosen phrase: potential biosignatures. Not life, not fossils, just chemical and structural fingerprints that could be consistent with past biological activity. They are also explicit about what this does not mean. It does not mean life has been discovered on Mars. It does not mean biology has been confirmed. And it does not rule out purely geological explanations. The true test will only come years from now, when these sealed samples are physically returned to Earth and analysed with laboratory instruments far more sensitive than anything that can be sent on a rover. But for the first time, scientists are holding in their data something they cannot confidently explain away as simple chemistry. So what we have is not proof of life, but the strongest physical case yet that Mars once hosted the conditions and possibly the processes associated with living systems. And that is what makes what comes next unavoidable. Because if this rock truly does carry the fingerprints of biology, then only two explanations remain. If the chemistry inside that rock truly is biological in origin, then only two explanations survive. There is no third option. Either life on Mars and life on Earth share the same origin, or life arose on both worlds independently. And both conclusions carry consequences that are difficult to fully absorb. The first possibility is known as shared biogenesis. In the early history of the solar system, Earth and Mars were bombarded constantly by asteroids and debris. We already know that rocks ejected from Mars have landed on Earth. Martian meteorites sit in museums and laboratories today. If life began on one of these two worlds early enough, it is entirely plausible that microscopic organisms could have been transferred from one planet to the other, sealed inside rock, and delivered intact. If that is what happened, then life did not emerge twice, it spread. Which means the moment biology ignites on one world, an entire planetary system can become biologically connected. Life would not be a local accident, it would be a contagion of chemistry, moving wherever physics allows. But the second possibility is far more unsettling. Because if life arose on Mars independently of Earth, then the process that turns dead chemistry into living systems is not rare, it is easy. Two neighbouring planets formed from the same dusty disk following different environmental histories, both generating life on their own. At that point, probability takes over. With hundreds of billions of stars in our galaxy and hundreds of billions of galaxies in the observable universe, life would not be extraordinary. It would be inevitable. Not guaranteed on every world, but common enough that the universe itself would be biologically busy, whether we ever meet its inhabitants or not. Either way, whether life spread once or ignited twice, the universe is no longer allowed to be sterile. And yet, when we look out into the night sky, we see no cities, no signals, no answering voices, just old stars and long silence. If Mars once lived, then the universe crossed a threshold long before we ever looked up at the stars. It means life is not a miracle reserved for Earth. It is a process, a natural outcome of matter learning how to arrange itself into something that can endure, replicate, and wonder. On at least two worlds in one small solar system, chemistry may have crossed that invisible line between the dead and the living. And if it happened twice here, then it has likely happened countless times elsewhere. Which means the universe may already be full of life, even if it feels empty to us. Perhaps most life never grows beyond microbes. Perhaps most civilizations never survive their own adolescence. Perhaps intelligence is common and endurance is rare. Worlds may awaken and fall silent again, over and over, for billions of years. Entire histories could rise and vanish without ever overlapping with ours in time. The universe could be teeming with life and still feel like a graveyard. And yet, here we are, on a small, warm world, orbiting an ordinary star, made from the same atoms as that ancient Martian lakebed. The same chemistry that once may have stirred in the waters of Mars now thinks, fears, hopes, and looks outward from Earth. Two planets, one origin of matter, possibly two beginnings of life. The universe did not have to try twice, but it may have. And if life truly is common, then the great mystery is no longer where it comes from. It is where everyone has gone. Whether Mars once lived, or merely almost did, the question is no longer whether the universe is capable of life. It is whether life is capable of lasting. Somewhere in the dark, on worlds we will never reach, the same question may be forming, looking back at us through their own long silence.